In this video, we're going to look at absolute value inequalities, all right? And we're just going to be messing with the greater than symbol for this one. So what this statement is looking for, it's looking for all values of x so that its absolute value is greater than 8. Now, if you remember the absolute value, all that means is its distance away from 0. So we're literally saying we're looking for all numbers whose distance from 0, all right, whose distance from 0 is greater than 8. All right, so here's 8 on your number line. So all the numbers that are past 8 have a distance away from 0 that's greater than 8. But also all the numbers out here, past to the left that are less than -8, they also have a distance from 0 that is greater than 8. So the way we're going to be breaking these down is, all right, we'll have two scenarios. We'll have just x is greater than 8. All right, so just the original statement. And we're also going to have x is less than, where we flip the sign, and then we just add a negative to this part. All right, and then it's going to be an or statement. I remember or statements are the ones that go on in two different directions. So if this picture, it's going to be hard to remember the idea behind this. So just memorize the rules if you have to, okay? All right, so we're solving this inequality. This has got a greater than symbol. All right, so it's a great or than symbol. So that kind of reminds you that it's that's an or statement. So we're going to have two versions here. All right, so we're going to have the regular version. So x plus 3 is greater than 4. Or, and then we're going to have the negative version over here, where we add a negative to that and we flip the signs. So x plus 3 is less than -4. And we're just going to solve both of these inequalities. So -3. And we'll get x is greater than 1. And over here, it's actually the same steps, just -3 from both sides. And you'll have x is less than -7. All right, so we would graph the solution set for this, which would be, let's see here, 0. We'd have +1 there, and it's an open dot, and we're saying it's greater than 1, so any value this way. And then here we'd have an open dot, excuse me, an open dot at -7, and we're looking for numbers that are less than -7, so -8, -9, in that direction. All right, so this would be our solution set for that inequality. So if we plugged in +2 or +3, that would satisfy this. Like if we plugged in +2 for x, it'd be 2 plus 3 is greater than 4, and this is equal to 5, and the absolute value of 5 is greater than 4. Right? I think I also want you guys to write your answers in interval notation here. So for this one, it would be 1 to infinity, but parentheses because it's an open dot. And for this one, it would be -infinity to -7. And we want to, it's one set of numbers, so we would union these two. All right, there we go. All right, one more here. So let's break it down into our two cases. All right, so we got the original. So 3 minus 2x is greater than or equal to 9. And then we're going to have the opposite version over here. So 3 minus 2x, we'll flip the sign and add a negative. Okay. And because it was a greater than or equal to symbol, this is going to be an or inequality. All right, -3 from both sides. You get -2x is greater than or equal to 6. Divide both sides by -2. All right, because you divided by a negative, we've got to flip our sign. And that one's solved on this one. We'll minus 3. All right, bring down our negative 2x. Negative 9 minus 3 is going to be negative 12. And we'll divide by negative 2. All right, because we divided by a negative, we'll flip our sign. Negative 12 divided by negative 2 is positive 6. All right, so we got an OR statement again. All right, so there's 0. We're going to have a closed dot at negative 3 and less than negative 3. We're also going to count numbers that are greater than or equal to 6. All right, so a closed dot at 6 going to the right. And if we want to do the interval notation here, it's going to be a bracket at 6 to infinity. We're also going to include these numbers, so that's going to be negative infinity up to negative 3, and a bracket at negative 3 because it's a closed dot. And we want to combine those, so union. And that'll do it.